Couple definitions here, and then how this is used. This is actually one of my favorite parts of all the graphing. I'm sure y'all will all agree with me. It's just going to be your favorite. Linear programming. Linear programming is a technique used to maximize or minimize a particular quantity represented by an objective function under a given set of inequalities or constraints. So the goal with linear programming is I have some formula here that I either want to maximize, let's say profit. If we have a business, clearly we would want to maximize our profit, right? Or let's say expenses, maybe we want to minimize our expenses, right? And so that guy is kind of off to the side. And then we have a list of constraints. Constraints are exactly what they sound like. Constraints constrain things, right? They limit things. Well, what kind of things would limit? Well, I mean, if you're baking pies and you're selling them, how much flour you have, how much sugar you have, how much fruit you have if you're making fruit pies, right? Those are limits because you clearly cannot make more than what you have, right? Or let's say you have some constraints on how much you're willing to spend on certain things, okay? Or how much time something takes to make. These are types of limitations that will constrain your function. And so for linear programming, this vertex principle says if I want to maximize something or minimize something, that will always happen at a vertex. And so we just graphed something and it created a triangle. Triangles have 3 vertices, right? Hence the term tri, right? All right, so what this is saying is if you want to maximize that function that represents that triangle, it will happen at one of the vertex, or minimize, it's going to happen at one of the vertices, okay? And so how does this help us? Well, let's say I have some constraints for my business. I can graph those constraints and it will create some polygon, typically of sorts. And then I can say, well, where's my maximum profit? And I can figure out where that would be. If I sold 5 apple pies and 7 peach pies, that's going to be my maximum profit, right? And so that's how this is going to set up these types of problems. These problems are going to give you a profit or an objective function, whatever your objective is. You're going to set that to the side, and then you are going to look at your constraints. You will graph the constraints. You will find your vertices, and then you will take the vertices and go back to that objective and see which one gives you maximum or which one gives you minimum, depending on what you're trying to find. All right? So let's look at this first example. Find the order pairs that will maximize and minimize the objective function z equals 3x plus 5y under the given constraints. State the value of the function at each point. So the first thing I want to point out is my objective function. What function are we trying to maximize and minimize? Well, it's this guy right here. Z equals 3x plus 5y. And then they have given us a list of constraints. In order for this to work, x has to be between 0 and 4. Y has to be between 0 and 2. And x plus y has to be less than or equal to 5. All right? So first thing is you have some interesting ones to graph. The first 2 are a little more interesting than the last one. The last one is a basic line. We know how to do that, right? X plus y equals 5 line. That's easy. But the first 2 are kind of strange. X is between 0 and 4. Well, let's think about that logically. If I'm talking about x, I'm talking about my x-axis. My x-axis is this guy right here. If x is between 0 and 4, then here is 0 and here is 4. And remember, x equals a number is just a vertical line. So this first constraint, I am going to graph it with just vertical lines. I'm just going to do vertical lines here. I am going to do a vertical line at 0, which technically I already have on my graph. That's my y-axis. Vertical line at x equals 0. And a vertical line at x equals 4. Now, typically you will find that these lines are or equal to. So typically on linear programming, all of your lines are going to be solid, typically, because your vertices are literally what you're looking for. And if they're not part of the graph, then that doesn't make sense, okay? So typically you'll find these are always going to be or equal to. Every once in a while it'll say less than, but typically or equal to. So I am going to do a solid line here at x equals 0. And then I'm going to go to x equals 4. And I am going to do a solid line there as well. So that is my x equals 0 and x equals 4. All right? Now, if I were to shade this, and I'll hold off shading, but if x is between here, then my shading naturally would be here, because that represents all x values between 0 and 4. Does that make sense? All right? So now let's look at y. Hopefully y makes a little more sense now. Instead of vertical lines, I'm going to do horizontal lines, right? I'm going to do a horizontal line at y equals 0. And I'm going to do a horizontal line at y equals 2. Y equals 2. All right. And if I want everything in between those, then clearly my shading would be this for these two red lines, right? Now, if I were to shade these right now, I would be shading this rectangle. This rectangle falls between the x values and between the y values. But I have one more constraint to graph here, and that's my line x plus y equals 5. Now, I'm going to graph this with intercepts, all right? Because my intercept for x is just going to be 5, and my intercept for y is just going to be 5 as well, right? 5 over 1, 5 over 1. So that's an easy one. I'm going to do my y-intercept, my x-intercept, and then I am going to cross, it's going to cross off the corner of that rectangle is what's going to happen here. All right. And for this one, it wants everything below that line. So now if I were to look at how is this going to shade, it's in my rectangle there, but also below that blue line. So it's actually going to be this guy right here. It's going to be this weird shape right here. Okay. So my first step of linear program is to do this, to graph all of my constraints. So my first step, graph your constraints. You're going to graph these. Your second step is to find your vertices. So I want to find all of my vertices for this shape, all right? This is a pentagon, it's 5-sided here, okay? So I should have 5 vertices, pretty straightforward. This one's easy here. What is this vertice? What's my value there? 0, 0, right? This one is also easy. This is 0, 2. This one's easy. That's going to be 4, 0. And for this one, they were actually pretty nice because I have a beautiful slope of 1, okay? So you can see that I don't even have to really do anything to figure out this. My slope here is 1. So this is actually going to be exactly what it looks like. This is going to be the point 3, 2. And this is going to be the point 4, 1. Now, we're going to do some with larger numbers, and so sometimes when you get to the larger numbers, you have to do your little exclusions or your eliminations, but this guy was nice. Those are my 5 points that I need to check. Now, on this one, they want me to both maximize and minimize this objective function. So now what I'm going to do is I'm going to take this function, and I'm going to say 3x plus 5y equals z, some number z that I don't know. And I literally just plug it in. So I take the 0, 0. 3 times 0 plus 5 times 0 equals clearly 0. Plug in my 0, 2. And I'm going to do this for all 5 of these. All right. And to figure out what my maximum and my minimum is pretty straightforward. The lowest of those 5 numbers is my minimum. The highest is my maximum. And so 0, 0 actually gives me my minimum, right? And 3, 2 actually gives me my maximum. So 0 x's and 0 y's gives me a minimum. 3 x's and 2 y's give me a maximum there. My minimum being 0 and my maximum being 19. So if I were talking about profit, clearly selling nothing is going to give me the least amount of profit. That makes sense, right? And selling 3 x's, whatever that represents, and 2 y's, whatever that represents, would give me my maximum profit. And my profit there would be 19, okay? So I will say most of your word problems will be enclosed figures, right? Because you're typically going to have like a scenario that's going to be closed in, right, when you do a figure. There are going to be times when it's like this one right here where it's open. So what we're about to do is one that is actually an open figure. It's going to be, goes on infinitely in one direction. And so if it goes on infinitely to positive infinity, you cannot maximize it because there is no top value. But you can minimize the function. And so that's what this one is. This one's a minimize function. It says minimize the objective function, and they just wrote it a little differently. Instead of having some other variable here, they just wrote it as f of x, y, which is fine. Still, you have an objective function of 5x plus 2y. So this one we're going to set to the side. We don't need it right now. What we need to do is we need to graph our constraints. All right? These first 2 constraints put limitations on just your x values and your y values. So remember, if you have an x value with a number, that is going to be a vertical line. And if you have a y value, that's going to be a horizontal line. So the first thing you want to do is graph these 2. And so the y is greater than or equal to 0 line there is actually just going to be your y-axis. And so your y-axis is where x is always 0. So we have a vertical line at the y-axis, and it wants everything bigger than that. So it's everything on this side of the y-axis. And then you have a y is greater than or equal to 2. And so that is going to be your horizontal line where y equals 2. And then everything above it, which is right here. And then we have 2 linear functions that are our standard sloped linear functions. They're not vertical and horizontal, so we're just going to graph those individually. Using your intercepts, your x-intercept for the first one is 4. Your y-intercept for that first one is also 4. And so you graph your y and your x-intercept, and then you're going to connect those, everything above it. And then you also have a second line here. Your x-intercept for this second line is going to be that 6 over 3, which is 2. And your y-intercept is just 6 over 1, which is 6. So we have a y-intercept of 6, an x-intercept of 2. And we're going to say everything larger than that one as well. And so we get this graph here. And they want us to minimize this. So we need to find the vertices. If we were to shade this for everything larger than the x equals 0, larger than the y equals 2, larger than the x plus y, and larger than the 3x plus y, you would get this region right here. And so they want us to minimize it, and we clearly cannot maximize it because it goes on infinitely. So we are going to minimize this by checking these vertices right here. This first one is 0, 6. We're going to check this one right here, which is at the point 1, 3. And then we also need to check this one, which is at the point 2, 2. And we are going to plug those into our objective function, which is 5x plus 2y. So when we plug in the 0, 6, 5 times 0 plus 2 times 6 gives us 12. 1, 3, 5 times 1 plus 2 times 3, that gives us 11. And then the 2, 2, 5 times 2 plus 3 times 2, that gives us 16. Minimizing, we have a minimum at 1, 3, and our minimum value is 11. And so that would be how you minimize. Whichever is my lowest value, that is my minimum. Solving a linear programming, write an objective function for what you want to maximize or minimize. Write a system of inequalities or your limitations, your constraints. Graph your feasible region. That's what we've been graphing. We've been graphing our feasible region. That is the region where all of these constraints overlap. Substitute your vertices into your objective function to determine which gives you either the highest or the lowest, depending on what they are trying to get you to do. All right? So in a word problem, they are not going to give you the objective function and the constraints. You have to do the objective function and the constraints. All right? So let's look at example 3. A company wants to maximize its profits from 2 snowboards, the Snow Pro and the Mountain Flyer. The company has a budget of $15,000 for labor, $27,000 for materials. The materials cost $50 for each Snow Pro and $90 for each Mountain Flyer. Labor costs are $50 for the Snow Pro and $30 for the Mountain Flyer. The profit for the Snow Pro is $25 and for the Mountain Flyer is $60. How many of each do they need to make to maximize the profit, and what will the maximum profit be? Lots of words. All right, but let's break it down. What is their objective here? To do what? To maximize their profit. That is the objective of most businesses, right? So my objective function is going to have to do with profit. Does that make sense? So my objective function is going to be a function about the profit of this business. Throughout this entire word problem, what are the 2 variables? So once I've set up my profit equation, you'll notice I'm underlining these. You want to get either some type of colored pencil or highlighter when you start doing these problems. Profit is $25 for this, $60 for that. I'm actually done with this particular sentence right now. I'm now going to look and see, what are my limitations? Well, I have a natural limitation here. Clearly, I cannot have a negative number of snowboards, right? So a clear limitation is that it has to be greater than or equal to 0 for both of these guys. Now, it doesn't mean I can't just produce one type. I can decide, well, that guy's not worth it, right? But I clearly have to stay in the positive with these. So that limitation's just naturally in there. I have 2 limitations that are just said right to me. What are they? I have a limitation on labor. What is my limitation? I have a $15,000 budget for labor. So all of my labor has to be less than or equal to that $15,000 budget. Now I'm going to find everything that has to do with labor, because this is my labor constraint. Okay? This is my labor constraint. Labor cost. I see another sentence here. 50 for Snow Pro, 30 for Mountain Flyer. So I'm going to say 50 for my Snow Pro and 30 for my Mountain Flyer. Those 2 must be less than or equal to my budget for that. All right? I have another constraint. What's my other constraint? Materials is my other constraint. What is my limitation on materials? 27,000. And now I'm going to find everything that has to do with materials. The materials cost is 50 for Snow Pro and 90 for the Mountain Flyer. So 50x plus 90y. Does everybody see what I'm doing here? All right. So now I have, I have my constraints and I have my objective function. All right. And while they look huge, don't they? There's some quick and easy things you can do. Anytime you have lots of zeros, we're going to get rid of as many as we can, right? So I am going to rewrite this labor guy, and I'm going to take out 1 0 for all of them, right? Divide the whole thing by 10. Does that make sense? Because at the very end, you're going to end up dividing across anyway when you solve, and that 10 is going to go away. So I'm going to say, I'm going to rewrite him to be 5x plus 3y is less than or equal to rather 1,500. Does everybody see why I did that? And I'm going to do the same thing with the next one. 5x plus 9y is less than or equal to 2,700. All right? They were also really nice in that I can easily get my intercepts with these, right? 1500 is divisible by both 5 and 3. And 2700 is divisible by 9, and it's actually divisible by 5 too. It doesn't look like it is with the 27, but there's zeros at the end, so divisible by 5 as well, okay? And so I'm actually going to graph these by intercepts. Now, it seems like I have huge intercepts, so naturally I'm not going to use 1, 2, 3, 4 as my dividers, okay? So when I do this first guy here, my x-intercept is going to be 1500 divided by 5, which is 300. My y-intercept is going to be 1500 divided by 3, which is 500, okay? When I do my intercepts for this next guy, my x-intercept is going to be 2700 divided by 5, which is like 540, right? And then my y-intercept is going to be 2700 divided by 9, which is 300. So I would do it in hundreds or 50s, personally. Every 2 would be 100 here for me if I were doing this. So when I graph this guy, I'm going to say this is 100, this is 200, this is 300. So this is my x-intercept. This is 1, 2, 3, 4, 5. So this is my y-intercept, right? Does that make sense? And then I'm going to, of course, connect those dots. And I have that. And then for the other one, my x-intercept is 540, so that's 400, 500, 600. This would be 550, so 540 would be about right here. My y-intercept is at 300 right there. All right. Now clearly I can see where it's going to be shaded, because it's all of these are less than. So this is my shaded area. If I am maximizing profit, do I even need to test 0, 0? Probably not. All right. I know where this one is. This guy is at 0, 300. I know where this one is. This one is at 300, 0. I need to know where this is, right? They were nice. I can just negate one of these and cancel it, right? Do it by elimination to figure out exactly where they cross. All right. Add down. -3, this -5 and +5 cancel. -3 and +9 give me 6. -1500, +2700 give me a +1200. So my y is going to be 200 here. If you plug it back in, you're going to get an x of 180. So those are the 3 that I'm going to test. I'm going to test these 2 and then that 180, 200 into my profit. And when you do that, you will find that this one is going to give you $18,000 in profit. This one is going to give you $7,500 in profit. And this one is going to give you $16,500. I actually maximize my profit 0, 300, only producing 300 mountain flyers, no snowboards. That's my maximum profit.